Good morning all. So the next topic is the VI characteristics of Zener diode. Zener diode is also similar to the PN junction diode. It is also a two-terminal device. So it will be also having the anode and cathode. So in the symbol wise there will be one Z representation in the symbol. That was the only difference between the Zener diode and then the PN junction diode in terms of symbol. And then the next thing is about the VI characteristics of PN junction diode. So similar to the VI characteristics in the case of forward bias condition, it will be similar to the PN junction diode. So the forward bias condition, there is no change in the Zener diode. It will be similar to the PN junction diode. So it will also start conduct after the threshold voltage. So the next thing is about the reverse bias condition. So when we are increasing the reverse voltage, it means when we are giving the potential, that is the negative potential to the anode and then the positive potential to the cathode. So the depletion layer will be widened and then a small amount of current will flow due to the minority carriers. So at one point the device will gets breakdown. Here the only difference is the device will gets breakdown is known as Zener breakdown, and then after that point the voltage will be constant, that is known as Zener voltage. So you can see that here the device, the voltage is very it's constant up till the end, and then even though there is increase in current, the voltage remains constant. So this was the reverse bias condition for the Zener diode. So when compared to the diode, you can see that the current increases drastically, but here the current increases linearly, and also here you can see that the voltage and current both are increasing, but here the current is only increasing but the voltage remains constant. This was the major difference between a Zener diode and then the normal diode. So that's why the Zener diode will act like a voltage regulator in most of the applications. So this was the VI characteristics in terms of reverse bias condition for a Zener diode. So the next thing is about the features. The Zener diode will operate in reverse bias condition similar to the normal diode. So it will also operate in forward bias and also in reverse bias condition, and also it will act like a voltage regulator and then sharp breakdown characteristics and then temperature stability and fast response. These are the features of the Zener diode. And then in terms of application, it will be acts as a voltage regulator and then voltage references and then the wave shaping, clipping and clamping circuit, and then it will act as a surge protector.